No, you were missing a very big thing. Like, it gave me the other file that you need.
I hope that's recording. Okay. Alright, so first of all, thanks to everybody that came to the workshop, because we didn't really get that much promotion, so thank you so much. Yeah, that's recording.
No,
alright, so this is the workshop on Intro to Offensive Security. Who here's done Hack the Box, Vuln Hub stuff before? Okay, that's good. So for those of you who don't know me, my name's Tristan Byro. I'm a senior at the New York City campus, majoring in IT and minoring in CS. I'm currently president of Cybersecurity Club, which is just the cybersecurity club at the New York City campus. I was treasurer last year, and before that, just a regular club goer like many of you. This summer, I was a cybersecurity intern at the MITRE Corporation, and I'm currently working there remotely, or working for them remotely. And before that, I was an IT technician at Pace ITS. I'm also an associate of ISC squared towards CISSP, which just means I passed the CISSP exam, and I don't have enough work experience yet for them to acknowledge me as a full CISSP. I'm also a CyberCorp scholar from Queens, New York. Really love powerlifting. I'm a Derrick Rose super fan for anybody who watches NBA basketball. If you don't think Derrick Rose is the greatest player of all time, you're very wrong. And resident workaholic. Huh? I just think Derrick Rose has done a lot for the city of Chicago, as well as Michael Jordan, but Derrick Rose is my favorite player of all time. Youngest MVP in NBA history. He's the greatest of all time. For any offensive security related workshop, we do have to throw up a disclaimer, because the stuff, the tools, techniques, and knowledge that you gain from a workshop like this can easily be used super maliciously. So Pace, nor myself, nor BergCyberSec are responsible for any of you no-gooders. Just what a company like Google might be able to handle, a port scan on their servers. They might just block you, but for a smaller, mid-sized company, they might see that as very malicious and it could harm their servers. So just act reasonably, protect yourself, because computer crimes are prosecuted very broadly, and it's not the intent of the result, it's the intent of the action that gets prosecuted. So just be wary of that. I always refer to my good friend Dwight Schrute here. I thought this was a pretty funny quote. Whenever I'm about to do something, I think, would an idiot do that? And if they would, I do not do that thing. So yeah, old impression, that's about it. So why is offensive security important? Well, it really goes without saying a lot of the times that it's very important to be able to think and act like an adversary, because for many reasons this improves your detection mechanisms, it improves your threat hunting, and it improves your overall counter-threat intelligence. So this just improves the overall security posture of your organization, and that's very important, because with the world today, all of these organizations are turning to the web. They have public-facing web servers and content, so being aware of the types of threats that are out there and the mechanisms that they use to attack you is very beneficial. And one of the manifestations of being well-versed in offensive security is the MITRE attack framework, which stands for Adversarial Tactics, Techniques, and Common Knowledge. And it's just this framework that maps various techniques to certain hacking groups, which are known as advanced persistent threats. And so the attack framework just provides a way to map all of these actions to different threat groups. And there's just this running joke that you can fit so many techniques into attack, because this is what their framework looks like. It's kind of overwhelming to look at first, but as you can see, it has various fields like initial access, execution, lateral movement in the network, and it's very interesting to look at, and I highly recommend that all of you kind of get familiar with this, because this framework revolutionized the cybersecurity industry and like counter threat intelligence as a whole. So if you're like pretty well versed with this, you'll be setting yourself up for some sweet positions. So you're here at this workshop, you're here to do stuff, but what are you going to learn? So we're going to go over some networking fundamentals, basic network enumeration, web application analysis, basic protocol analysis and exploitation, post-exploitation methodology. And we're going to go over a little bit of like documenting your findings and like what you do, because that's a very important part of any offensive security engagement. And most importantly, like I said, we're going to learn how to think like an adversary, because that's why we're here. We're not going to spend too much time going over networking stuff, because networking in of itself can have its own workshop, and So I'm going to cover like some basics, and if you have some questions, feel free to stop me, but we're not going to spend too much time on it. So in any conversation about networking, it's important to be familiar with the OSI model, which stands for Open Systems Interconnect Model. It's a mouthful, kind of, but all that means is just this framework of interoperable protocols that allow our devices to communicate with each other, like very seamlessly. There's 7 layers to it: the physical data link, network layer, transport layer, session layer, presentation layer, and application layer. And these layers just exist because they're just trying to group certain protocols into certain sections, because they just kind of operate at those levels. And a good way to remember the layers is that this little thing here: please do not throw sausage pizza away. And it starts from the bottom: physical, data link, network, transport, session, presentation, and application. And it's really important to be well versed with the OSI model, just because like when you're having conversations or interviews, they'll ask you to describe like a layer 7 attack, or you might hear something like, what is a layer 7 firewall? And it's commonly referred to as an application firewall. So it's good to be familiar with the OSI model because it applies in a lot of situations. In IT, like you'll hear often like 95% of problems are layer 1 problems, like physical problems, things that aren't plugged in. So I'm not gonna really go into the protocols here. I know I listed a lot, but I'm just gonna go over each level at like a high level to kind of explain what goes on there. So the physical layer, as you could imagine, is everything that's physical. Like it's everything that you can touch. Like even the beacons that wireless access points like emit, technically that exists on the physical layer because it's physical waves. The data link layer refers to communications that are happening like within the network, like on the same LAN. And so you'll often hear the term frames. So that just refers to the data that's being sent on a local area network. The network layer deals with communications across networks. So like that's where IPv4 and IPv6 operate at, and like various routing protocols. The transport layer deals with like how traffic should be transferred. So it determines like, should this application be connection oriented? Like, does it matter if all of the data is received in the right format and in the right order? So for example, if you're like downloading a file, that would be TCP packets, because you want to get every single byte of that file, otherwise you get a corrupted file. But if you're like streaming video, like YouTube videos, watching Netflix or something, that's generally UDP traffic, because if you're trying to make sure that every packet being sent in like a video like was received, that would be very slow. So like sometimes when you see like your video stop and then skip ahead, it's because like probably a few packets were dropped. But it doesn't need to be connection oriented, because like you can figure out, you're like, oh well, I probably just missed a word here in the video. The session layer, I didn't list protocols there because the thing with the OSI model is like it's very like general. Like sure, there are protocols like mapped to each layer, but they do kind of bleed over into different layers. So like often like you'll see like these tunneling protocols here, like layer 2 tunneling protocol. that will you'll sometimes see that mapped to the session layer because tunneling has to do with a session. So the session layer is the most self-explanatory one, I think. It deals with sessions, and there are various protocols that handle that there. The presentation layer has to do with like formatting of data, making sure that that data is just readable on every system it goes to. And the application layer is the highest level, which means it's the most user-facing level. It's the applications that we like actually interact with and like the protocols that handle those communications. So that's like HTTP, HTTPS, and the others that are listed here. So in a nutshell, you just have to think of the OSI model in like a top-down way. And we can see that here. So when you're sending data like across a network, that process is called encapsulation. So it starts from the application layer and just starts wrapping it and adding fields and headers to the packet with the various protocols. So you can think of encapsulation as like sending a letter to somebody. Like you have your actual payload, which is the letter, and with all the information on it, and you put it inside an envelope, which would be like the different header information and things like that. And you send it through a medium, which in this case would be like UPS, I don't know. And the person who receives it de-encapsulates it, so they check out the header information, they're like, yep, this checks out, they open it up, they take out the payload, the letter, and they get the data. So encapsulation and de-encapsulation is kind of how that works there. And this is actually a Wireshark screenshot of, like, if you were to examine like a particular packet in a Wireshark capture, there's a little section in Wireshark where you can actually like visualize the different fields and flags that each protocol has. So it's very, if you're really curious as to like how DNS works, for example, you would just like open up a web browser, go to google.com, and then like stop your Wireshark capture, and then like look for DNS packets, and then you could open up the DNS field and like see what kinds of flags and data that it sends along with the packet. Because I don't think you have to do this, but if you're really interested in understanding the intricacies of each protocol, this is a good way to do it, because there are some really cool, I forgot the name of it, but there's a really, really cool DNS exploit from like years ago, and you should definitely read about it, but I forgot the name of it off the top of my head. Any questions so far? Like, is everybody good? Do you need me to like slow down at all, or is this like a good pace?
Good.
Cool. Okay, so we're gonna talk about NAT, just because it's what we're using today in terms of routing traffic outside of like local networks. So NAT stands for Network Address Translation, and this is the routing protocol that really put a bandage on the IPv4 problem. Could anybody tell me what the problem with IPv4 is?
Running out of addresses.
We're running out of addresses because it's a 32-bit address, so that's only 4 billion something addresses, right? But today each of us have like multiple wirelessly connectable devices. Like we have laptops, phones, tablets, whatever. So you can't just assign a unique IP address to each device. Like you can see really quickly how 7 billion people in the world, like maybe half of us have devices. You can see how quickly like you would run out of addresses. So NAT introduced public and private IP addresses, and basically the default gateway of each network, like the routers, are assigned the unique public addresses that are able to route traffic out to the internet, and every device behind it, like our laptops, desktops, and stuff, are assigned non-routable IP addresses. So for example, if we were to look at our IP address on our machine by running ipconfig, you'll see like right here, it says my IP address is 10.86.96.250, but if we all went to Google and looked for, where's my IP? We would all have this, and so like clearly like that's a different address, but that's the public facing IP address of the default gateway. And this address is the address that we have on the network, so our router knows where traffic's coming from and where to send it back to. And so that's what NAT provided. Aside from like putting a bandage on running out of addresses, NAT also adds an additional layer of security because the router acts as a proxy. So when traffic is getting sent out onto the internet, the other servers and stuff, they only see that public facing address. So they don't know that it's actually coming from like this machine. Only the router and its routing table knows that. So like when responses get sent back, the router said, oh, well, this person sent out that request, so I'm just gonna send it back to them. So it's neat in that way, in that it provides that additional layer of security. And this is just like a little joke. Actually, so whenever there's networking problems, you know, people are always like, oh, it's always DNS. And for those of you who don't know, DNS stands for Domain Name Service, and it's the protocol that resolves IP addresses to host names. So like if you were to ping google.com, like you would see it return like an address. Or if you were to ping the club website, it would return like an IP address. And so DNS is just what helps machines resolve those host names. It's always like a DNS problem. Literally this morning, I got a Slack message that like there was something wrong with like the APIs that our team was developing, and he said word for word, it's not resolving DNS. And like I just like kind of like laughed to myself really nerdily because I just thought about this joke. Yeah. Okay. Alright, so that's like the end of the networking crash course. Any questions? Okay. So we're going to get into the actual fundamentals of offensive security now. So there's rules of engagement, recon / enumeration, exploitation, post-exploitation, which jumps into maintaining persistence, and documentation. These are just like the kind of general steps that you take in any offensive security engagement. And the rules of engagement are very important because it's the predefined contract guidelines that you and your client agree upon before you attack their system. So generally, who here knows what the difference is between a red team and a pen test? Between red teaming and pen testing?
Pen testing is like you're hired by a company to come and figure it out, like check out the vulnerabilities. Red team usually malicious intent.
Yes-ish. So like they both can be contracted, but the main difference is that pen testing engagements have like a much more narrow scope, meaning like you might just be testing against like one server. Whereas red teaming is just like this broad, like we're just gonna unleash our wrath on your network. So those differences matter. So if you violate the rules of engagement, you could cause some serious damage to your client's network, and like in turn that costs them money, and it's not good. And often you'll hear the terms black box, crystal box, and gray box. And so if you're a CS person, programming person, you'll be familiar with the term black box, which just means that you send input in and get input out. You don't really know the inner workings of what's going on. And so in the scope of offensive security, a black box test just means you know nothing about the network. Your client provided no information, and often those provide the most realistic results because you know the team is going in blind and they're just throwing things at the network and seeing how it responds. A crystal box or white box test just means that the client gives you everything. They're like, this is our infrastructure, this is what we're running on them, here's the versions, blah, blah, blah. And so it allows you to take a much more granular and strategic approach, and you know, you don't end up wasting time on like testing random things that aren't vulnerable. And a gray box test is, as you could imagine, just a mix of both. It's you have some knowledge of the network and the systems, but not everything is revealed. The next step, and what I think is the most important phase of any offensive security engagement, is the recon and enumeration phase, because this is your information gathering phase. This is where you are doing all of your research, you're identifying assets and vulnerabilities, really just planning out your attack. And there's a few tools that you can use for that. The biggest one being Google. You'll often hear just Google it, and it might come across as snarky, but I kid you not, Googling things is one of the best steps you can take. And Google also has this thing called Google hacking, where you can use specific operators in the Google search tab to make your searches more specific. But we're not really gonna go into that. We will be using Nmap and Dirbuster in the lab, so you'll see how those work, and And they're just network reconnaissance tools. And you'll see how those work really quickly. Nessus and OpenVAS are just web application vulnerability scanners. So Nessus has a free version, but it's not as good as its paid version, obviously. But they just run tests against a web app and return results. And they take reconnaissance a step further in that they actually try to test a vulnerability and return back whether or not it's actually vulnerable or not. Whereas things like Nmap will just identify them, or identify open services and stuff. And then you have social engineering, which is a really fancy way of saying just be manipulative. This is just being good at speaking and getting information you want out of people by convincing them that you're their supervisor or somebody higher up from a different location. The next step would be exploitation. So this is taking all that information that you gathered, all of the different attack vectors that you identified, and exploiting it. So there's a few resources that you have for that. There's MITRE's CV database, which is it stands for Common Vulnerabilities and Exposures, and it's just this database that's maintained with various vulnerabilities for various protocols, services, etc., and it assigns them a rating. So this is kind of bad, but we're going to give it a 1, and then it has some really severe remote code execution vulnerabilities that are rated as a 10 in terms of severity. There's the Metasploit framework, which Kevin, our vice president in the back, is actually going to be giving a workshop on November 1st, and basically it's just this really handy framework that pen testers and red teams use to I want to say standardize their attack. It allows you to manage sessions, and it has various modules written in that you can just run attacks with a command. It's really cool. You have exploits, offensive securities, exploit DB database, which just contains exploit code that are mapped to certain CVEs and stuff. And the biggest part about exploitation, recon and enumeration, is reading and really learning about the vulnerabilities that you're researching. Because, for example, if you pull code off of exploit DB and it doesn't work, you're oh, well, this exploit doesn't work, or this service isn't vulnerable. When in reality, it really could be, but because you're just running a script without actually understanding the intricacies of the vulnerability, you don't know what to adjust in the script in order for it to work. So whenever you're using somebody else's code, you just always have to vet it, make sure it's not doing anything it's not supposed to, and see how you can modify it to meet your needs. Because you're not always, exploit code is not always going to work out of the box. The next step is post-exploitation. So this is after you've gained your initial foothold on a system or a network. I think this is one of the coolest parts of offensive security, because this is where you start, living off the land, per se. You start creating privileged accounts, you try to survive reboots, you move laterally throughout the network or try to pivot to other networks that you otherwise wouldn't have access to. And it's really just, trying to stay there. And you hear a lot of breaches, like the Marriott breach that happened, that got exposed, a few months ago. the hackers were in the Marriott systems for like 4 years. So they did a really good job in the post-exploitation phase. And there's a lot of tools out there, especially for like you CCDC folk, like you'll be very familiar with PowerShell Empire and Armitage because like the red teams love those. So understanding how to actually use those frameworks and what that activity looks like will really help your detection mechanisms as well. There's also Caldera, which is another MITRE plug. It's an automated adversary emulation framework that my explanation would do no justice for, but it's really cool. And there's several scripts and programs that you can use in the post-exploitation phase to just gather more information about the system and the network. And a lot of post-exploitation is also done by hand because, again, like I said, these automated scripts and stuff might not always work out of the box. And so understanding exactly what you're looking for and what you're trying to accomplish is important because then you can achieve that manually. And so maintaining persistence, we're going to talk about this a little bit, even though it's pretty out of scope for this workshop because, you know, we're just going to do a challenge and like get root and that's it. But it's still important to talk about maintaining persistence, especially in the scope of incident response and threat hunting because, like I said, there's a few CCDC people here, and just in general, this is the phase where attackers do the most damage. So simply like looking for things like suspicious accounts, like new accounts that shouldn't have been there, bind shells, hiding from the running process list, and looking at like beacon traffic, which is when an attacker has a program on the system that calls out periodically to their command and control server to get more malicious code. This is a really interesting phase, and the attack framework actually has a lot of information on this phase because, you know, this is really how APTs do most of their damage and exfiltrate data out of the network. So looking into this and doing a lot of research on maintaining persistence is really cool. Because actually, if you go on YouTube and type in, I think his name is Jared Stroud, it's like post-exploitation with Vim. Vim is the text editing program, and he has like an hour talk on just like the different ways that you can escalate your privileges and maintain persistence with Vim. It's a text edit, it's crazy. And so you should definitely take a look at that. So workshop necessities, all you need is just Kali Linux. I had an extra challenge at the end, which was the Mr. Robot Vuln Hub, just because it's Mr. Robot. I don't know if any of you guys have watched that show, but it's awesome and you should. But we probably won't get to that, which is fine. But if you want to, you can do the Mr. Robot Vuln Hub, create a write-up for it, and we'll put it up on the website. So if you want to get some clout to show like employers and interviewers and stuff, definitely do that. All right, so we're gonna dive into the lab now. So for those of you who don't know, Kali Linux is just an offensive security Linux distribution that just has all of the offensive security tools you could possibly need. Parrot OS is another good one, so if you're using Parrot or Kali, doesn't really matter, you should be fine. They both have everything that you need. We could talk about, you know, who here understands virtual machines? Who here doesn't really get them that much? It's okay if you don't. So in a nutshell, VMs are just these operating system images that are packaged into files, and you run them in a hypervisor. And so they're considered heavyweight processes because they're just like these full operating systems that consume a lot of host resources. So like they take up memory, they take up disk space, and they use some of your CPU cores. So that's what a VM is. So on the same breath about talking about a VM, there are security benefits to a VM-based lab. The main thing being that it segments your lab network from like your actual host network. So say you're like analyzing malware or something, it's way better to do it in a virtual environment, because if the malware like ends up doing something malicious on the VM, it's not going to propagate, or hopefully it doesn't propagate into your host network. And there are several networking configurations that you can use in VMs to add to that additional layer of security. So as we talked about before, you could use a NAT configuration for your VMs, where your host machine will act as the proxy for your VMs. So every VM in the NAT network can talk to each other, but they'll also be able to route traffic out to the internet through your host, and then your host will send that out through the gateway, and that's how they communicate out to the internet. Additionally, you could opt to use host only, but you won't be able to communicate with the internet that way, because it just creates a host only network on top of your host, and the VMs in the host only network can only talk to each other, which obviously is much more secure than NAT. But if you're doing like hack the box challenges and stuff, you won't be able to like Google stuff through your VM. All right, so we're gonna jump into the actual lab now. So any questions so far? Everybody's good? Okay, who here's heard of Hack the Box? Okay, so pretty much everybody here is familiar. For everybody who's not, Hack the Box is just this free pen testing platform that you can create an account on and legally hack machines. It's really, really useful, and especially anybody who's looking to go for their OSCP cert, Hack the Box is like the #1 technical resource aside from the actual labs you get for the cert. And it has like the coolest way to get an account, because you have to hack your way to get in the login code. So we're gonna do that. So if you open up Kali, and go to hackthebox.eu and scroll down their homepage and click join. You get this page. And so the #1 thing to think about when you're doing like any offensive security engagement, you have to like remember what it is you're trying to achieve, like the scope of what you're doing. In this case, we're trying to get an invite code to make an account. So what should be the first thing that we do here?
Check the source.
Exactly. So whenever you're doing like web application analysis, you should immediately check the source code of the page. And so you can do that by doing Control-U or going into developer tools with Control-Shift-I. And so you have to look for things that are interesting. So remember, we're looking for an invite code. So looking at the source here, what stands out?
Make it bigger.
Can you not see that? I'm sorry. I don't know how to make it bigger.
Control plus.
I don't think that one scales.
Oh, okay. Yeah, my computer's just getting destroyed right now.
Yeah.
Is that better?
Yeah.
Okay. So what stands out here, looking at this?
Invite API.
Yeah, that looks pretty interesting to me, because we're trying to get an invite code, so an invite API script sounds like the direction that we should go. So if you click on the link to the API, or you could go to debugger. Sorry, my laptop is not doing well right now. But if you go to debugger, you'll see the JavaScript folder and invite API. So if you click on the invite API.min.js file, you'll see this long list of stuff, and it contains a lot. It's like kind of annoying to look at first because it's just long lines of JavaScript. But if you go to the end, you will see a bunch of words, and from what you can see here, who can tell me like what these are and then what we should be looking at?
Functions.
Right, so these are JavaScript functions, and if we look at the list of functions here, there's a few whatever ones, and then you get towards the end and you see verify invite code and make invite code. So if we remember what we're trying to accomplish here is we're trying to get an invite code. So we don't need that function because we don't even have an invite code to verify yet. So make invite code makes the most sense here. So to run a JavaScript function that exists already on the web page, in developer tools, if you go to console, you can type in the function. Don't forget your little parentheses. Oh, spell that wrong. And if you hit enter, you'll see we get a response. We get a 200 response, which is just the HTTP code for like, okay, like this is good, it went through. If we expand that object, we can see there's data that was sent back. And we get a string, you can't really see that, we get a string, and it also tells us the encoding type, and obviously this is done deliberately, but it's a base 64 string. So base 64 is just an encoding mechanism that was developed to aid in the transfer of binaries and things like that. So to decode this, if you open up your terminal, everybody see that? Is that good? Good size? Bash has a built-in function called base64 or command, and we can echo that string into base64 to code. So base64 is the command, and -d is the decode flag. And so in echo just echoes what you give it. So we're echoing the string and piping it through to the base64 decode command. So if we paste that string in there, I think I forgot some equal signs. We get a response here, and it says, in order to generate the invite code, make a post request to API invite generate. Sorry, that got tacked on at the end there. But we need to send a post request to API invite generate. That's the endpoint we need to make a post request to. So what tool can we use to make a post request from like the command line? Curl, exactly. So it's really easy. We don't need to send this any data. You start by typing curl x to just denote that we're telling this what HTTP code we need to use here. So curl x post, we're sending a post request, and we just need to give it the URL. So https www hackthebox.eu. Everybody good? Okay, so when you send that post request, you get a JSON response, and we can see we get another string, and it tells us it's encoded. And if we remember from the first string that we got, we can also assume pretty reasonably that this is base64 encoded. The biggest giveaway for base64 is the equal sign at the end. It's usually just this. You'll see like a mix of these kinds of characters and either one equal sign or two equal signs at the end. And you should always immediately think like that's base64. So all we need to do to decode that is do the exact same thing. We'll just copy that string. If my computer's up lagging. Okay. So if you just do the same thing and echo that string through to the base64 decode command, you'll get your invite code. And then you just copy that string, or like that little code, and you can paste it into here, and you can make your account. So if anybody is doing that, I'll give you like a couple minutes. Okay, so has everybody created their account if you don't have one? Or do you need a couple more minutes? Okay, so after you create your account, you'll probably get dropped into this page. And if you go to access, the little access tab here on the side, you can't really see that at all. Oh my god. So there's a little tab here on the side called access. And so in order to access Hack the Box's lab network, we need to VPN in. And so they provide an OpenVPN certificate that we can use. And so you can regenerate it if you want, or just download it by clicking Connection Pack. And it'll download it and send it to your downloads folder. And then I would move it into like a pen testing Hack the Box folder just so that it's there all the time. So like I saved mine in here. And so all you need to do to VPN in after you download your OVPN file is just type OpenVPN, the name of the OVPN file, and hit enter. Pretty straightforward. Yeah, if it's taking you a minute, just Control-C and try it again. And once you're good, it should say initialization sequence completed. Don't Control-C out of that, because you'll kill your VPN session. So just open up a new terminal tab or terminal window. And so now we are on the lab network. So the box that we are going to attack is this machine called network. I chose this machine just because like it's pretty straightforward and includes a lot of really good concepts in it. And because I think we're actually doing really well on time, we can spend a lot of time like explaining it. So each machine on Hack the Box has an IP address, and normally the first step you would take in like an offensive security engagement is like run a null scan on the entire subnet or network that you're testing to just enumerate all of the active IP addresses. But Hack the Box makes that really easy for us because they just give you the address of the machine, whichever one you so choose to attack. In this case, the machine of the IP address of networked is 10.10.10.146. I'll write that over here. And one thing to always remember about Hack the Box machines is that the names always kind of have something to do with the box, like at some point. Like, it'll never occur to you while you're doing it, but once you finish it, you'll just be like, oh, wow, that was so clever. Yeah, so now that we have an IP address, is everybody okay so far? Everybody's good?
Wait, so after we VPN in, we open a new window?
Yeah.
Okay.
Salvatore, are you good? You nodded your head no? What's the problem? You're good?
Open VPN thing also.
Oh, yeah. You're good? You're good though? Everybody? Okay. Alright, so we have an IP address. We exist on the network. What should we do?
Scan the system.
What tool is a great tool to use for scanning?
Your main,
Yeah.
I use nmap just because it's the standard.
Yeah, so we're going to use nmap, like literally never not use nmap when you're scanning a system. Because we already have the IP address of the system that we're targeting, we can run a very, very fine-grained scan on it, and we can do this through various flags. So I'll probably make this a little bit bigger. So we're going to use the -v flag for verbose, which just means, you know, show me what you're doing as you're doing it. The SC flag for default scripts. As you get more into using nmap and stuff, nmap has like a lot of built-in scripts that are useful for enumerating different things. So this flag just says, just use your default scanning scripts. We don't really know what we're looking for, so just do your best. And the SV flag stands for enumerate versions. So this, when nmap scans a service and it detects it, it's also going to like perform a banner grab and return what service version it is. And that's very, very important information because typically if services are outdated, they're vulnerable, and you can then start looking into that version and any vulnerabilities associated with it. We're also going to do -p-, which means scan all 65,536 ports. So this scan usually takes a bit, but it's fine. And then we're going to use the -OA flag, which means output all formats, and the string that I gave it there, network, is just what you want to name those output files. And so output all formats just returns like greppable text files. And this is a very good thing to do because you don't want to have to rerun a scan every single time, like you need to go back and look for like information. So by writing the nmap output to these files, you can have access to it very quickly. And the last thing you need to give nmap is the IP address of the machine. So I'm gonna run this scan, but like Control-C out of it because I saved the scan, so we can save ourselves some time. But if you want to like let the scan run, like by all means do so. So if you run it, you can see it starting, and boom, 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 it starts giving you output. But I'm gonna Control-C out. But like you also see like it tells you when it detects like an open port and like if it's a TCP port. By default, nmap will only scan TCP ports. You can also opt to scan UDP ports, but that takes a really long time because, as we mentioned before, UDP is connectionless. So it's really hard for nmap to determine, like, is this thing actually alive or not. So Oh wow. I just overwrote scan files. It's okay. I'm pretty sure there's only 2 ports open on this box when you run the scan. SSH, port 22, and port 80. You could let the scan run, but other than SSH and port 80, it doesn't return anything else particularly useful. But we did discover, like I said, port 80. So what protocols are typically associated with port 80? So if 80 is exposed, we can assume that there's like a web server running unencrypted, because HTTP usually runs on port 80. So if we go to that IP address in our browser, we get this back. Here. So, hello mate, we're building the new face smash. No idea, like this is very clearly not helpful at all. Like, join us at the pool party. So we have this web server, we have this web page, we know it exists, but you know, what do we do here? Like, what should our next step be?
Can crawl through the directories for weird files.
Yeah. So how would you go about that?
You use dirb.
Dirb. You can use dirb. So the tool Drew mentioned, dirb, is just the command line version of DirbBuster. And they're very straightforward to use. Basically, like Nmap, DirbBuster, dirb is a network, it's like an enumeration tool, and it'll use a word list, typically full of just like common directory names, and make requests using those names and let you know like if there was a success or not. Like, does this path on this server actually exist? So we're gonna use DirbBuster just because it's a GUI and it's very easy to use, but you can use dirb absolutely. So to run DirbBuster, all you need to do is type DirbBuster in your terminal, and it should bring up the GUI. So all you need to supply DirbBuster is the URL, the word list, and I mean, you could mess with the options here, but you know, you don't really have to, especially for this box. But yeah. So we need to give it HTTP 10.10.10.146, and the word list we're going to use, I know it's hard to see, I'm sorry. If you go all the way to the top level directory by clicking this little button up here, just go all the way to the top, go to user, USR, share, and then when you're in this window, if you don't click on anything but type word, it'll jump to the word lists folder, and we're then going to go into the DirbBuster directory and choose directory list 23 medium.txt. It's a moderate sized word list that usually always meets your needs for these challenges. And so you're just going to select that, and is everybody good so far with that part? Okay.
Is it in the DirbBuster folder?
Yeah. So after you choose that word list, you just hit start, and DirbBuster is going to do its thing. It'll return some basic directories, but it'll eventually start returning some interesting ones. So we see it returned photos, uploads, icons, which typically just has images. We can let this run for a little bit, and then we'll see upload.php. So after you get upload.php, or right now, you could just quit your dirbuster scan just because it's not gonna this is what we need. So we know these directories exist, so we should go check them out. So if we go to uploads, that's neat. Then we're gonna go to photos.php. Oh, sweet, welcome to our awesome gallery. And then we should also check out upload.php. Oh, so we can upload some images. That's pretty cool. All right, we're done, right? Like, we've completed the enumeration here. So what should we do next? We found some directories. We got photos, we got uploads, we can upload files. Sick. Now what, dude? What should we do next?
Maintain our presence on the network.
Not yet, because we still haven't gotten our initial foothold. So right now, our goal is to gain access to the system, right? So there are obviously a bunch of ways you can do that, generally speaking. But from what we've looked at so far, what stands out to you in terms of what we can use here to gain access to the system?
Upload.
Upload?
Yeah.
Yeah, so this page here, uploads.php, is, no, that's wrong, it's upload.php. It's interesting for a variety of reasons. The main reason being we can upload files. So, whenever you see like some upload functionality on a web application that you're testing, you should always try and mess with it to see how you can bypass its validation checking. So what that means is, sure, we can upload images, right? But can we trick the server into accepting some malicious code to give us access to the system, right? So this is where the concept of reverse shells come in. So a reverse shell is literally just, a shell is what we have, like this terminal session, this is a shell, right? And a reverse shell would be having the server execute something to make a callback to our attacking machine, right, who was listening for a connection back, and when we get that connection back, it executes a shell on the server. So that's a reverse shell. It's just like waiting for a connection from the server and then executing some code to get a shell. So a go-to reverse shell that I use all the time, if you go into your search tab and type in, okay, before we do that actually, who can tell me, you know, what the server-side code might be? Like what code is running server-side?
PHP.
PHP? What makes you think that?
Upload.php.
Exactly. So PHP is a dead giveaway because every PHP file has the .php extension. So luckily for us, there are some really nice people on the internet that have written PHP reverse shells for us. So if we go to Google and type in pen test monkey PHP reverse shell, it's the first. You can see these links are purple because I go here frequently. Go to the first link. and just download it. It says gzip file, and you just have to unarchive it or just extract it from the GUI. So when you get it, it should look something like this. Like you'll get it in a tar file like this, and we could be fancy and extract it from the command line, but like just double click it and drag the folder out. And then in the folder, you'll see this PHP file, php reverse shell.php. So if you open it up, is that good to see? Like
All plus.
kind of.
Maybe because you're in VM. If you go up to the hamburger menu next to save,
Right here.
it comes in. Yeah. No, maybe not.
All right. That's okay.
Well, figured.
Okay. So when you look at the file, if you scroll down a bit, you'll see there are a couple values we need to change. These will be different for you, but you need to set the IP address to your IP address on Hack the Box's network, and you can pick any port number above 1024, just because the ports below 1024 are like specially reserved ports that typically have services running on them. So you can just pick any 4-digit port above that. So in order to figure out what your IP address is on Hack the Box's network, just run ifconfig, and you'll see the ton0 interface, which is the VPN interface that gets created. And you'll see your IP address right there. So I need to change mine to that. And so the reason we're putting our IP address here is because we're letting the script know where to call back to and on what port we're going to be listening on. Question? You sure? Huh? No, like, you can ask questions. Okay. Okay.
I looked down and then
Okay. Where did I lose you?
reverse shell.
Like the concept of the reverse shell, or like?
No, it was downloading and then,
Oh.
yeah.
Okay.
Yes.
Are you? Is it all downloaded now, or?
It's downloading.
Okay. So.
It's not open, I don't know what you do.
Got it. So, now
Thank you.
so where you download it in the
Where's the IP that we have to change in the PHP file?
Oh yeah. Just scroll down.
He's just, it's like he took a full abstract. That's exactly. Took out random steps. That's exactly. It's like
And then you can change it here.
That's
He's
mine.
Yeah. You want your ID red.
It doesn't matter what port.
Yeah. Just anything above 1024. you good in the back? Yep. All right. If you guys like need me to slow down or like have a question, like please stop me. Like don't be afraid to just stop me and say like I lost you somewhere. Okay, so everybody seems like they're good to go now. So after we do that, we can just save that and exit the file.
How do you save it in Vim?
In Vim, you hit escape and then shift colon. Well, of course it's cut off right there. But shift colon, and then you do write, W for write, Q for quit, and then exclamation point, and that just says write to this file and quit.
You don't need the exclamation point, do you?
Probably not. That's just like habit. You can probably, yeah. You don't need the exclamation point. Alright. So, you don't have to use Vim to edit the file, by the way. You know, whatever Nano, Vim, what's another one? Emacs? Yeah, whatever floats your boat is fine. Okay. So, now we have this trusty reverse shell. And we know we can upload files to the server. So let's try uploading this file and see what happens. Like, we've done it. We've owned them. Stupid it. Oh. We can't upload a PHP file because it's not an image file. So what do we do now? Like, oh. Who has any ideas? Besides Dan and Kyle. What should we do here?
You could just change the ending, right?
We could change the file extension, sure, but let's give it a try.
No, wait.
Okay, let's change it to what should we change it to? Like JPEG?
Sure.
Alright, sick. Haha, we've got him. Oh, it's still invalid. What should we do?
What if you just add a JPEG to the end of it?
Oh, so like keep the PHP extension,
Yeah.
but also add, but also just add JPEG.
Yeah.
Okay. We've got him now.
Oh, I know,
Damn. What should we do?
It's best to just hide the PHP inside the image. And then you can
Oh, like
extract
embed
it.
the PHP file?
Yeah,
in
you
it?
can do that. And then extract it once it's uploaded. Actually, you wouldn't be able to.
We'd be able to extract.
Yeah, you wouldn't be able to extract
There you
it.
go.
What if we just cry?
Cry? We can absolutely cry.
Give up and go home. You're like good security.
I highly encourage you all to cry. It's good and cathartic. Okay, so clearly we've had some really good propositions here, changing the file extension to trick the server, but its checking is a little bit more in depth than that. So what we can do is we can actually modify the request to trick the server in a little bit more in-depth way. So a very, very handy tool is BergCyberSec, and right on the sidebar of Tally, I mean, you can't really see it here, but BergCyberSec, if you scroll down a little bit, the logo looks like, kind of like that. And so BergCyberSec is just a web proxy. So what it will do when we set up BergCyberSec is it will intercept requests from localhost. So from your machine, like when you send out a request, Burp will be listening and it will catch the request and it will display some really cool information, and we can modify it and then forward it onto the server. So it allows us to really be tricky here with the server and get what we want. So because Burp is a proxy, it's going to be listening on a port. So by default, burp listens on port 8080, and you can see this if you, does everybody have burp open? Okay. So if you go to the proxy tab and click options, you'll see under proxy listeners up there, it'll say 127.00.18080. So that's the port that burp will be listening on. Okay, so if you're in Firefox, I'm not sure how to do this in Chrome if you're running Chrome on Kali, but it's probably very similar. But in Firefox, if you go to this little options menu up here, well, oh my god, it's the far right icon on the browser with the 3 lines. Open that up and click Preferences, and then go down to Advanced and click Settings. And so this is where we can set our proxy settings. And so right here, Firefox defaults to no proxy, but all we have to do is check manual proxy configuration, type in 127.0.0.1 and specify port 8080, and then just check use this proxy server for all protocols. So it'll do that for HTTPS and whatever traffic else, and the ones listed there. Everybody good with that? Sure? Okay. Alright, so once you do that, just click OK. And now you can click Browse, and we are going to give it our reverse shell file, which might still be renamed like this, which is fine. We're going to click Open, but before we do that, before we submit the request, I want you to go back to your terminal, and we're going to use a tool called netcat to set up our listener. So netcat is like one of the most versatile tools in your toolbox. You can use it to listen for connections, to create connections, to execute commands, to transfer files. It's known as like the Swiss Army knife of tools. So to set up our listener, we just type nc-nvlp, which these flags just stand for verbose, listen on this port, and I think the N flag stands for like no DNS lookup or something. I'm not too sure. If anybody knows what that is, tell me.
Yeah, it doesn't resolve IP addresses.
Okay.
It just goes directly for the IP.
Yeah, okay, so yeah, no DNS lookup. So we're just telling that cat to just listen for a connection. We don't care about the host name. And so we're gonna listen on I'm gonna listen on port 9999 because that's the port that I specified in the reverse shell file. So if you pick something different, use that port. Okay? So we're gonna hit enter, and we're just gonna let it hang. We're just gonna leave it there, and that opens up a socket on our machine to wait for connections. So now we have our manual proxy set up, we have burp open, and we have our listener. So we're gonna hit go, and you'll see that your web page should hang. It should just start like loading, and this is because burp intercepted the request. So we can see that we get this request, and we can actually analyze. I know this is kind of hard to see. Can I use that zoom in? No.
Try window. Top left. Top left. Top right.
What? Where am I looking?
You see where it says burp, intruder, repeater?
Above proxy, above scanner.
Above scanner.
Ah! Oh my god, what?
Oh, window. Oh, view under repeater? No.
Try Control Plus again. It always be amazing.
Try clicking inside the text box though.
Control plus cycles through the tabs.
Oh, I know.
That's okay, I'll just explain it. So basically up here, these are just all of the HTTP request headers. So in an HTTP request, like these are the headers that contain certain information that the server is looking for. So Most notably, we can see it's a post request, which means that we're sending data to the server, and we're sending it to that path. We can see the user agent field, which just says like, oh, this is coming from the Firefox web browser. And there's a couple others here. There's a refer field, which is where the request is coming from. So it's coming from our IP address, or well, no, the request is coming from 10.10.10.146 upload.php, because we're sending the request from this page. Most notably though, the most notable headers are content type, content disposition. So right here, we can see this header is denoting our file name. So I forgot, I think Dan and Kyle were the ones that said, and Jonathan, that we can just change the file extension. And that is the first step in tricking this server. However, we can see that, it already determined the content type to be an image/JPEG because of this extension. So we've already fooled the content type header. If we didn't leave that, if we didn't have the .jpeg there, the content type would say like application PHP, because it would be able to determine that, well, this is not an image file. So who knows like how the server is determining what type of file it is and why this still isn't working? Because we've already renamed the file, we see that it's detecting it as an image file, but it's still not getting uploaded onto the server. So, elaborate.
The hexadecimal first couple characters that denotes what a file is uploaded to a server.
Yeah, so what the server is doing as an additional check, it's what Kyle mentioned is called magic bytes. It's the first every file, the first 4 bytes has like, it's a unique sequence of bytes that determines what file type it is. So it's saying, oh, like this is JPEG, oh, this is JPEG, but then it gets here and it's like, oh, like this is PHP, like don't add this to the server. So we can literally just append bytes here to tell the server that like this is actually an image file. So if you go to Google and you type in like magic byte table, like a Wikipedia page will come up with the various magic bytes. But we don't have to do that. I kind of remember the GIF one off the top of my head. And you might be wondering, like, Tristan, what the hell? Like, we named it JPEG, why are we using GIF? Well, it's because we know that although these parameters matter here, it's not really relying on that for its final check. So as long as we provide any valid bytes for like an image file, it should accept that as a valid image file. Before we do that though, if you right click on like inside the request and click send to repeater, you can also do Control R. That sends it to the repeater tab up there, like you'll see it highlight in orange. And what this tab does is it allows us to modify our requests and send it forward to the server and visualize the response. So we can like continuously keep doing this in this like same window without having to go back, turn our proxy off, turn it back on, intercept, blah, blah, blah. So this allows you to just kind of like keep messing around with your request. Okay. So what we would do right here, right above PHP, you know, it could be right here, it could be right here, but just right above the PHP, type GIF 89 lowercase a semicolon. Do it type. And so those are the magic bytes for a GIF file. So what we've done now, looking at this request, is we have renamed the file extension to bypass that check. We've modified the content type, although indirectly, to bypass that check. And we have added magic bytes to trick the server in its final check. Is everybody good with that, or do you want me to explain that more or explain that better? Good?
Where do we?
You can append them right above. Oh, you don't have to do it in Berg, not the actual text file. So once we've done that, we can click go, and we'll see the response that says file upload, refresh gallery. So before we go back and switch pages, remember to go back and turn off your proxy. Otherwise, Burp is gonna keep intercepting like your requests, and you're gonna be like, why is nothing working anymore? So just always remember to turn it off. So if we go back and look at our reverse shell, or like our shell, we can see that we still didn't get anything yet, but that's because we haven't executed the script that was uploaded to the server. So in order for a reverse shell to work, you have to actually get it onto the server first, or the target machine, but you also have to have a means of executing the file. So like this, we uploaded a PHP file, it's a script, it's code. It's not gonna do anything unless you execute it, or unless the server executes it for us. So it tells us to check the gallery, right? So we remember that path being photos.php. If we go there, we can see, it had some other images here, whatever, and then we see that, which is our reverse shell, so conveniently placed there. And you can also see up here on the tab, there's some loading. So whenever you're on the web and you're making a request to a page and you're waiting for it to reply, you'll always see it loading, which means it's doing something. So what is it doing? I don't know, Tristan. What if we checked our terminal? We have a shell. And that, folks, is how you get a reverse shell. Woo! We've done it. No, that's it. We're done.
Didn't you need a
Where's
flag?
the flag?
Okay, yeah, so we're doing Hack the Box, so it's one thing to get this, but now, so the steps we've covered so far are recon enumeration. Our rules of engagement were literally just I don't know, we didn't really go over that for Hack the Box, but don't worry. We've done our recon enumeration, we've done our exploitation, and now we have entered the post-exploitation phase. So our goal now is to really look around the box. So in these boot to root challenges, as they're called, you're looking for these things called flags, as Drew mentioned. So Hack the Box has a user flag that we can get and a root flag. So the user flag is the flag you get when you log in as an unprivileged user. And root is the gold. It's when you become the super user of the system and you can do anything. So there's always a few steps involved after gaining the initial foothold on the system. So if we run, the first thing that you should always do after you get a reverse shell is type ID, and this will return what user you are and what group you're in, just so that you can get an idea of where you stand with permissions. Also, don't control C right now, because if you do, you'll kill your shell session. But because our file is still, if I were to just kill it right now, damn. If I set up my listener again and refresh the page, I'd get my shell back. So that's what Andrew mentioned in maintaining persistence. This is a method of maintaining persistence. Our shell, our reverse shell script is still on the server, so if we lose our shell, we can just refresh the page. Alternatively, we can make this shell more usable in a variety of ways. So one step after gaining your initial foothold is kind of figuring out what useful tools there are that exist on the system for you. So we can see that this is a Linux machine, because when we log in, it tells us this is Linux, right? Pretty straightforward. So on most Linux distributions, if not all, Python is installed by default. So we can figure this out by typing which Python, and it returns us the path for the Python binary. And this is like my favorite way of improving my shell. It's by, I'll write it over here because that might be a little bit easier to see. So, as most of you may or may not know, Python, you can run Python commands and execute Python code from the command line. So, if we know Python exists on the system, we can type Python -c to denote that like we are trying to execute a command, right? Single colon, or quote, import pty. So for those of you who aren't familiar with Python syntax, import pty, this is just a library in Python standard library that creates like a pseudo terminal session for you. And then we're going to call pty.spawn, which is the function that spawns the terminal. And then inside pty.spawn, we need to give it a shell. Like we need to give it a type of shell to execute. So I should probably write that a little bit with more space. So we're telling Python to import its terminal module. We're telling it to spawn a bash shell for us. So that was a little bit loaded of an explanation, but in order to determine what kind of shells and where they're located before you run that kind of command, you can type which bash to determine the path, and it's user bin bash, but I think that should work just fine too. So if we type this into the terminal, and hit enter, we'll see that we get a bash shell, which is denoted, like you'll see it says bash, and up there was sh, which was just kind of like not as good of a shell. It was the original Unix shell. But we can still upgrade our shell a little bit more to have like tab completion and stuff. So type, like while in this, type Control-Z. It'll send that process to the background, stty raw-echo semicolon fg. So like what that's saying is we want to turn this pseudo terminal session into a usable terminal, and we want to bring it back to the foreground. So we want to bring that process back to us. You hit enter. It's going to look ugly for a second, but then you hit enter again, and you can Control-C and it doesn't break. And the last thing you can do, in order to use like clear, like if your terminal screen fills up, like it'll say term environment variable not set. So we can just set that by doing export term equals xterm, which is just setting the environment variable that includes the clear command. So then we can use clear. So I'm just gonna write that there too. So, is everybody good so far, or like, do you want me to go over anything there? Yes, no, maybe so. Going once, going twice. Okay. So, what should we do now? We've upgraded our shell, we have access, we have some form of persistence here, but like, now what? Like Drew mentioned, we need to look for the flag, but like, how do we do that?
Try write history, right? Does that work?
Okay, so good first step. We realize that we're in the top directory here. We're in the slash directory. So typically, there are a couple things that you can do. You can search. Kevin, you want to say something?
I was gonna say, you could try who am I, see what you're running as.
So we're the Apache user. So what could we take from that?
You could see what's in the Apache user folder, see if there's anything lurking in there.
Okay, so where are user folders typically located?
In the home directory.
Right, so if we were to, so home is the directory on most Linux and Unix systems that just contain user folders. So for every user on the system, they'll typically have their own directory in home. So if we were to cd into home, and you have to add the slash at the start there to denote that we're coming from the root directory, and we type ls to see what directories are in there. We don't see Apache, but we see Gully. So we can type ls-la to look at the permissions on this folder. So who here is familiar with like how permissions work on Linux? Dan, explain. What does this output tell us?
GUI has read, write, and execute permissions. Everyone else can read and execute, and then the owner can read and execute, and then everyone else can read and execute. So they can't write to that file, but they can read it.
Right.
And execute it. If it were executed.
Precisely.
Yeah.
So is everybody okay with that? That makes sense? Okay. And when you run ls-la, Dan didn't see this, it was kind of cut off by accident, but when you run ls-la, it'll also tell you like
Oh, it's a directory.
that it's a directory. So because we have read and execute, so what Dan was saying was the user Gully, right here, the user Gully can read, write, and execute in this directory. Anybody in the group can read and execute. And everybody else, whoever you are, Apache or, I don't know, nobody, you can read and execute the directory. So because we have read directories on it, or read permissions on the directory, we can cd into it. And if we run ls, oh my god, the user flag, let's get it. Oh damn. We can't read it. Now what? So we can enumerate who can by running ls-la. And for those of you who don't understand what ls-la is doing, it's listing all the files in the directory as well as hidden files or hidden directories. And it's really good to get into the habit of listing all files, directories, and hidden stuff, because often people will just add the dot in front of like a file name or a directory name, and it won't be visible if you run regular ls. Like we can see the .ssh directory, which contains like public and private keys for SSH, doesn't come up by default. Don't worry about the SSH directory though. That was just for the sake of the example. So we can see that the only person who can read the user.txt flag is Gully. But as Kevin pointed out, if we run whoami, we are not Gully. We are Apache. Damn. So with that said, when we're looking at the directory here, there are also a couple other files here. There's crontab.gully and there's checkattack.php, both of which sound particularly interesting. And what should we do now? Also, who could tell me what a cron tab is? Okay, so a cron tab is
Schedule stops.
It's like a task scheduler on Windows.
yes. So the equivalent of a task scheduler on Windows in Linux is a cron job, and they just run commands or processes periodically given some interval. This could be like every minute, every second, every hour, every day. You get the idea. So if we look at the contents of that, like first we need to see if we can read the contents, which we can. Root is the only person that can write to it, but everybody else can read it. So if we were to cat crontab.gully, we see this little weird syntax, but what this is saying is it's just saying every 3 minutes run this script with the PHP interpreter. So if we look at the contents of that script, we can try to evaluate what it's doing here. So we're trying to get the user flag. We're trying to read the value there so that we can put it into Hack the Box, get some points. Cool. But we don't really have a vector yet of doing that. But we do have a cron job and a script and access to the script that cron job runs. So whenever you're escalating privileges or trying to, you should always look for services that are misconfigured or cron jobs, because they will run periodically, and if you can modify or inject something into the command or process that it's running, you can just escalate your privileges that way. So when we look at this script, we can see that it is setting a few variables here. It's setting the path to var html/uploads, log path, it's the to variable is gully, blah blah blah. We're going down, we can see some regex there, and then we see a loop here. So does anybody want to take a jab at what's going on here and how we can leverage this to escalate our privileges? Remember, we're trying to get the user flag, but only Gully can read that flag. And there's a cron job that runs as Gully, and it's running this file.
So it's sending mail to whoever the user is. So wherever there's the to address is, which I don't see it being set here. Guess it's up top. To Gully. So you could change. Oh, you can't write here, right?
No, we can't write. We can only read.
So we know that he's being sent. He is being sent something every 3 minutes from this for each item in that list.
Right.
Can we edit the cron?
We can't edit the cron. We don't have write permissions in this directory or on this file.
And we don't have write permissions on this file.
No.
Would we have write permission, or we would have write permissions to the temp directory though, correct?
Yes.
Okay. And there's brand name, if you scroll back up to where the variables were. Log path equals temp attack dot log. Add large, Gully. It doesn't say require lib.php. I would check to see if we could write to lib.php and see if we can alter anything in there.
But to say that, I think your thing is it's gonna upload everything in the uploads folder with a dot in the middle, according to the regular expression. So you could probably create a file and put it inside the uploads folder.
Yeah, that's the track we want to take here. so what this script is doing, well, before we get into that,
Standard.
what, do you guys see any functions that, you know, look like they can aid us?
Put content. Check.
So the exec function in PHP is what's going to aid us the most here, because that's the system function that runs code on the system. So when we look at this for loop, we can see up top it sets a variable path to, as Ryan pointed out, the var HTML uploads directory. And so what it's like, I'm no PHP whiz, and you don't have to be either, so don't worry. But just looking through it, it's checking for each of the files in the directory, does index.html exist? If yeah, continue. And then it's going to run some check here, it's going to do something. And then we get down here. So without worrying too much about the semantics and like syntax of PHP, it's basically storing each file name in that directory in a variable called value, right? And so then down here, we can see that value variable gets passed into the exec function. So as Ryan said, we could probably write a file in that directory. So first things first is we're going to run an ls-la on var html uploads, and that is disgusting. I should probably not do it on uploads. But oh wow, how convenient. We can write to that directory. So if we go to var html uploads, and hit ls, we can see that there's a bunch of picture files in there. And so for those of you who don't know, var HTML is what's known as the web root. So like any web server that's running on a Linux server, it defaults to like putting its content there. So we know that the cron job that runs as the Gully user runs every 3 minutes. We looked at the script that it was executing every 3 minutes, and we know that it's reading each file in the directory, it's looking for one file, and then continuing on. And I think it was just like clearing out files or something. And we know that it's passing that variable into the exec function. So how can we absolutely abuse that?
So since the owner of that that file was root, that you can do anything you want, technically, because it should have root permissions when you run it.
Yes, but the cron job's running as Gully, so whatever gets executed as Gully is going to run with his permissions.
No, okay. I mean, you could just change the ownership of the file.
We could, but I don't think we can.
Oh, no.
No, I think so.
If you run the file in Gully would need permissions to be able to change ownership.
Yeah, you can, have his own file.
No, because you had to access root privileges to be able to change to root.
Yeah, but if the script's running with his permissions, he can change his file that he created, which is the user txt one. Right?
So you're talking about, let me just clear that. In Gully, you're saying
who owns the
who owns
user.txt?
check PHP. So root owns it, but when the script gets executed, it's not running as root.
Well, either way, the user.txt is owned by Gully. So even if the cron job or the whatever we're executing is with Gully's permissions, we should be able to change the owner of.
Oh, so you're saying that we can
TXT.
just append a command to change the owner of that file,
Yeah,
and then we can just read it.
exactly. Or just have it broadcast to users or something.
Okay, yeah, like You can absolutely do that.
Contents. Yeah.
Yes, you can absolutely do that, but how would we do that in the directory? Because like, so we know that we can achieve some form of command execution, but how can we do that in that directory? And also, you don't just want to like maybe change permissions on a file to allow you to read it, because you want to elevate from the non-privileged user that you are to a different user, because Gully could have access to things or permissions that Apache doesn't have access to. So even though we get the user flag, like that's something checked off our list of things to do, however, we're still kind of stuck as this low privilege user. So that's definitely the right track. Aha! First try.
Just edit that, you'll be golden.
Just gonna cut that old part out.
Yeah, no, it's live.
Who is for the forms?
I'll be back at 7.
I'm not back at 7, I'm still whatever it was.
Probably try it.
Real quick, what was all that?
Yeah, you're up to 8.
Okay, so what I just did there was, so I got the initial, when you get the callback, you get a shell with the sh shell. So I just upgraded it to bash with Python. And then I sent that session to the background. And I ran that command stty raw echo because it just, it upgrades the terminal session in that you can like tab complete and control C without losing the shell.
Cool.
And then the last part, export term equals xterm, was setting the environment variable to like use like commands like clear and stuff. Yeah. So that's super handy.
Yeah. Now that's not persistence on the box, that's just, obviously, because if you have persistence, you want to actually
Yeah, so like,
that's just upgrading to the better shell.
yeah, so technically we do have persistence right now because the PHP reverse shell is on the server. So if we did lose this, we could refresh that page with our listener and get it back.
But because they reset the box.
Yeah, so like, that would be like terrible persistence because we wouldn't survive a reboot.
Right.
So, yeah, but you know, typically for hack the box and stuff, like you will never survive a reboot. Alright, so going back to the cron job, actually maybe I should wait a couple more minutes. Everybody's here? Okay. So, going back to, now that we're back, we are trying to escalate to Gully or any other privileged user in order to read the user flag. We know there's a cron job that runs every 3 minutes that reads files in this directory and stores them as a variable and passes them to the execute function. So Ryan mentioned that we can write to this directory, which we can. So this part is not exactly, well, okay, I'll let you take a jab at like what we can do here in order to get the cron job to execute something we want. So it's reading files in the directory, passing them into an exec function. What can we do here?
Put something malicious in this directory that gets passed into the exec function.
Yes. What malicious thing?
I have no idea.
Wait, so it's not passing what's in the file, it's passing the name of the file?
Yes.
Or does it just make a file that says, you know, I don't know, cat user.txt or whatever?
Exactly. So we can create a malicious file that is a command. We can make the file name the name of a command. But instead of just, like I mentioned before, instead of just reading the user flag and like just doing that, we want to become a different user. So you should open up another terminal window or tab and set up another listener on, you know, whatever port you want. I'll do this one as 7777. And so in this directory, in var www html uploads, we can create a file with the touch command. And because we're gonna have spaces in this file name, because we're gonna be running a command, we wanna make sure that it's in quotes. And so we're gonna start this file name off with a semicolon. So who can tell me why we're using a semicolon here?
Because that's the PHP syntax for, I don't know what it adds, but I know it's probably because it's gonna be passing that into a PHP command, and you want it to run once it gets, the name gets passed, right? You want it to execute appropriately.
Right, so the semicolon, so the exec function, it's executing commands with the bash shell. So the semicolon is just a means of run this, and then this, and then this. So we're telling, when it reads in the file name, it's gonna do whatever operation before that is in the exec function, and it's gonna read in the semicolon, and it's gonna go, oh, I have another command to run. So we're gonna do NC, so this is why I mentioned netcat before, and why it's so versatile. The -e flag means execute, so we can tell netcat to execute like a program or a command. And this is some bash syntax here, so we're gonna do $ parentheses, which bash, parentheses, and we're gonna give it our IP address. And the port we're listening on. So the reason I put $ which bash is that is telling, because we can't just give it the file path, because if we did that and tried to write the file, it would say, oh, like this doesn't, like it would give us a really strange error. So like, let me just show you that instead of explaining. So if we put user bin bash, we would get an error that says cannot touch this, there's no such file or directory. Because it's taking that in as an actual path. And so it's trying to like it's trying to do stuff here, and it's like, I don't understand what you want. So by giving it we're just basically telling bash to store the path of bash into this variable. So when we run this command, we can see that it creates the file. And if we run ls, well, you can see there are other people in the box here, but we can see that it created the file. And so when that command gets executed by the PHP interpreter and runs the exec function, bash is going to see that, and it's going to go, okay, I'm using netcat, I'm executing this, and oh, let's get the path for bash, and then send it there. So all we have to do now is wait. Roughly 3 minutes. Let me just make sure I got my IP address correct. I did. Huh? This is Tmux. Yeah. Tmux 10 out of 10. Highly recommend. So while we're waiting, does anybody have any questions? Or, you know, it doesn't have to be specifically about this, maybe something we did earlier.
How did you set up clear again?
Oh, export term equals xterm.
Okay.
Yeah. Make sure term is in all caps.
And what is that actually doing?
It's setting the terminal environment variable to include commands like clear. So like certain environments don't use certain commands, so that's what that's doing.
Yeah.
Oh.
No, just, I'm gonna give him like $10 worth of sheet. Just in this.
Any other questions? Sal, any questions?
There you go.
Good.
You just got connected.
Oh, aha! I did not anticipate this. So,
I hope you know it. Jesus.
so now we can see that netcat returns some output saying, oh, you got a connection from 10.10.10.146. If we run ID, we're gully. So this is, I was going through this again last night just to make sure I had every step like good to go. And I did this part, and it returned me a shell as Apache again. And I was like, you got that? Okay, I really don't know why that happens. It's probably because somebody like screwed something with the machine, but have no fear, try it again. And if that fails, do not reset the box, because that will kill my session too.
No, I'm gonna do this. When you got killed, I didn't get that.
Oh really? Oh well, I don't know. Well, but okay, don't worry. Just follow along. So, but at least you got a connection back though. So we know that the cron dropped executing. It just didn't do what it was supposed to. So we've now elevated our privileges to gully. So we're gonna do the same thing here and upgrade our shell again because we have like a really terrible shell. Okay, so I'm just going to do the same thing. Okay, so now we can go back to the home directory, to Gully's directory. And if we run a word count on the count on the amount of characters in the user.txt file, we'll see it returns 33, and that's how you know like that's like the flag. I'm not going to display it here because I'm not supposed to just like give away the flag, but obviously you guys can cat the file, get the hash, and once you do, you can go back to hack the box with the hash, and you just go to the machine and you can submit the user flag, and then like you just get points and stuff, and like you can like rank up, and it's really cute. I love it. So as you can see, I've completed the box because yeah, and then so like up here, like there are a couple buttons to own user and own root. So if you have the user flag, put it in the own user button. So I'll give you a minute to do that if you want. Just get some hack the box clout.
Tristan, do me a favor?
Yo.
Back, on the first shell, we still have the first shell? What are the permissions for the file you created? Is it owned by Apache?
Yeah, so
There's only two of them. I think we can figure out which one was yours.
so
The one that uses which.
my file will be Apache. It'll be owned by Apache, group Apache, whatever. But the reason we get a shell back as Gully is because we are running the process. The cron job is running as Gully.
So it's running the command that you're passing as Gully.
Yes.
It should be.
Yes.
But no.
Yeah, like I don't know why that happened.
Should I just create a new?
because you can't create a file and make Gully the owner because you're not Gully. So yeah, like I really have no explanation for that. It's just like sometimes it really do be like that.
Won't try again.
Okay, so is everybody good to go again, or any questions? You got it?
Turn it off and turn it on again.
First try, baby.
Always.
So, okay. So we've got our user flag, we got our hack the box cloud, we got some points, but we still have one step left. We want to own this system. We want to become root. We want to have all the privileges. But how can we do that? So we're in the post-exploitation phase. We've already pivoted to another user and elevated our privileges a teeny bit. We can now read files that we couldn't have otherwise read as Apache. But now we want to become root. And does anybody have any ideas or things that we might look for in order to become the omniscient user root? Because we're just going now, like we can enumerate things like what groups we're in, which is unsurprisingly just going. So like what kind of information could we look for now? We could look for more cron jobs and stuff. Any ideas? Just like shoot some.
You should be able to read the as a password file right now. Let's see that. There you go.
So we could read the Etsy password file, but
The shadowed one.
if we could read Etsy shadow, oh my god. Okay. So Etsy shadow permission denied is the. Pardon? Yeah, so only root can read Etsy shadow because it's the file on Linux systems that contain password hashes. So like if anybody could just read the hashes, they could easily authenticate as other users. So that's a bit of a dead end. So what else should we do here?
I would just try logging in with a blank password.
Huh?
Rudy, blank password, so just switch it up. See what happens. You never know. Root Tor. Root Tor.
Admin.
You could try. Okay, that was like a joke, but those aren't terrible guesses. Because like,
Password?
whenever you're trying to like log into like a service or another user, like always try default passwords like admin, password, admin 123.
1, 2, 3, 4, 5, 6, bro. Come on now.
Exactly, because like
Accuracy.
they work. They work. Like we assume that people will not do that, but they do. And especially in these kinds of challenges, like people start thinking way too difficultly about things and like, oh, I reverse shell this for blah 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 persistence, execute PowerShell Empire, owned. But like, it's really important to, yes, remember the scope of what you're doing, but keep it simple. So there's one really good resource for Linux Privesk on a fantastic blog. If you go into your search tab here and type in got milk with a 1 and type in Privesk, it's the first link. It's basic Linux privilege escalation, and it's just this entire blog post with commands that you can use to enumerate the file system and enumerate interesting permissions that you as the user might have. So what this tells us is it provides like ways to enumerate sensitive files that we might be able to write to, sensitive files we might be able to read, and things like that. there is a script that we can use to like automatically enumerate the system, but this box doesn't really provide like a straightforward way of doing that. So I want you all to take a look at this blog page, scroll through, and tell me if you find like any interesting commands that would help us in escalating to root. And hopefully my shell doesn't die in between them.
It's so hot here.
It is. Shut the window.
The door.
Yeah, it's insane. I'm bored on the line.
I wanna call security. and show me some background.
They turned it off?
Yeah, they
In a
turned it off.
computer lab?
It's like, yeah.
You go to Peace, don't you?
Oh, you're right. I should have seen this coming.
They're
I'm
not
just gonna
expecting
bleep that part out.
I'm gonna put like a little.
So while you guys are looking up stuff, like any questions or anything? Everybody's pretty good so far. Matt? What's your name in the back? I didn't. Michael. Okay. Anybody find any useful commands or?
My terminal broke, so Stan taught me the art of turning it off and turning it back on again.
That guy's a forward thinker right there.
New shells fixes old shells.
He's fixed 3 of my shells so far.
I love it. Well, the teamwork makes the dream work.
Speaking of teamwork, I don't know what we're doing right now.
Okay, so you have your gully shell? Okay, so I went back to Firefox and I was like, well, we need to escalate now to root. We got our user flag. So the next step is getting the root flag. So we know the path we have to take, but how do we get there? So the Got Milk privilege escalation blog, if you just go on Google and type in Got Milk Privesc. And so it's just a blog post that shows you all the basic Linux commands that you can use to escalate your privileges or just enumerate useful information. And the reason we're doing this and not just like running the automated script that you can use, you can type in lin enum on Google, and it'll return like the GitHub for that repo. And what lin enum does is it just takes all those commands in that blog post and runs them. And we could have used this script, but like this box doesn't have like a very decent means of transferring files. Like it doesn't have wget, it has curl, but like it has netcat and stuff, but in this case it's a little bit easier to do the privilege escalation manually, just because when I sent lin enum to this box, I used secure copy and I had to like open up SSH on Kali and like it's not fun. So yeah. So right now it's just like look through that blog post, look for anything that we could use to kind of guide you in the right direction. We're looking for, I don't know, like maybe files or commands that we can run with elevated privileges. So how can we figure out what commands or programs we can run with elevated privileges?
Paste on
Oh, Control Shift V.
This is why you use Nano.
I know that, but I'm trying to be better. Okay?
What do you say? I'm trying to be better.
Alright, so the best way is you cat the file, you copy it, and then you write a new file with the changes.
Ah.
Oh my gosh.
I don't need any
Big
editor.
brain. It's that 200 IQ right there, baby.
No editor needed.
The system builds it in for you. You need an editor for it. Jesus.
So,
Open it up on the thing itself.
anybody find anything useful, or do you just want me to get on with this part?
We've got 30 minutes, couple.
Yeah, I know. This last part doesn't take, should take about 30. Okay, so one of the go-to things you should check for whenever you become, I should have introduced this really when we got the shell as Apache, but whenever you get logged in as a user, there are a few default things that you should check for. You should check things like operating system version and the kernel version, because if the kernel is outdated or if the operating system is outdated, there is some exploit code that might exist that will allow you to run it and immediately escalate to root, and that exploit is what's known as like a rootkit. But kernel level exploits are often very risky, because if you mess with the kernel and it doesn't respond in an intended way, you could brick the system. So if you were to check the way to do that, to check operating system version and kernel information on Linux and Unix-based systems, is by running uname-a. And so this will just return the kernel, the host name, what the CPU architecture is, which is all that right there, the x86-64, so we know that this is Intel 64-bit CPU architecture. We can see the kernel version over there. The reason I'm bringing that up is because there is this exploit called Dirty Cow. I don't think this kernel is vulnerable to Dirty Cow, but it's really cool and you should look it up, and it's one of the easiest ways to get root, but no kernel is that outdated anymore. So the next thing that we would look for after determining that, okay, operating system version is fine, kernel looks all good, is you would run the command sudo -l. So what this does is, if this user can run any command or program with sudo, it will list that out. And so, who here knows what sudo does? Not Danbar. Anybody could take a jab.
Elevating standard user to a root user.
Nailed it. So what Dan said, or sorry, what Andrew said. Sudo stands for super user do. So when you append sudo to some command, it tells the bash interpreter, tells the shell, tells the system to run that command with root privileges. Run this as the super user. So we can see, and then often running sudo, trying to run something with sudo will prompt you for that user's password. In this case, we can see that we can run this script as root without providing a password. Fantastic, right? So let's try running it. And that's the other thing. If you're able to run some program or script with sudo, you have to provide it the full file path. Otherwise, it's going to look for it in your current working directory, or it's not going to parse that properly. So just provide it the full file path. And we can see it's asking for like interface name. I don't know what that is, but okay, let's say BergCyberSec is the best club ever 2019. Keep coming to our meetings. Interface proxy method, I don't know, yes. Interface browser only, okay. Google Chrome. Boot proto, what? And, okay, so we get an error here that says device gully 0 does not seem to be present. And you can see that it was running this, if up eth. So what can we determine from what this script is trying to do?
Trying to configure a new network interface.
Yes. So this is where like the name of the box comes in. It's like networked. So we're dealing with some networking stuff here. So we can assume that this script is trying to bring up the gully 0 network interface, but obviously that's not like an actual interface. It's not a default interface, so it's looking for it and it's just like, what? So what we should do is, I actually forgot the path there. We should try and read, what this script is actually doing. So we can cat it with user local sbin, and then we're just gonna add the name there, change name.sh. So I know that might be a little bit hard to read. Okay. So at the top here, it's kind of cut off. You can see the hashtag exclamation point, that's a shebang. That's what that pair of characters is called. And the bin bash. So when this program is run, it's telling the system to run this program with the bash interpreter. So it's going to assume that all of this is properly written in bash syntax. And so there's a lot going on here. But we can, just from running the program, we know that it's running through these names here, which are all variables, and it's asking us to assign some value to them, right? It runs through name, proxy method, browser only, and boot proto, all of which have no significance, at least in what we're trying to do here. What is significant, it's very similar to something that we did as the Apache user. So if we're looking at this, how can we leverage this to become root? Because we know we can execute this script with root privileges as super user. We kind of know what it does. We know it iterates through that stuff and asks us to assign it some values. But again, we're kind of stuck looking at a script, and we kind of get it, but like, how can we abuse it? How can we leverage this?
You can pass a variable through the echo command.
So
Or you can pass in regex.
So what's happening here, I should probably do a better job of explaining. So for var,
Read x.
so x is just determining So the regex here, this regular expression, is just making sure that the input you provided contains valid characters. Like this is like a whitelist of characters. And so var, it's storing each, as this loop goes through, it's taking name and storing it into var. And then it prompts you interface name, and it waits for our input, right? So then it checks our input, it checks to make sure that, so x is our input. So it's reading x and saying like, does this match up with our regex here? If not, wrong input, try again. And then echoes the interface again. And so once all that's good and done and you provide some valid input, it echoes your input. It echoes the values stored in each of these variables into this file, right? And then, so this would be like the interface's config file. So the ETH0 interface and ton0, they have a file like this that just has configuration information. So once all is good and all is said and done, it tries to bring it up. So it executes the values in this file and tries to bring it up. So we can store input into these variables that get executed here.
Right.
So what can we do?
Just store more commands in there.
Exactly.
Yeah.
Did you want to?
I was gonna say store commands to elevate privileges wherever.
Exactly. So we can go back to running this script with sudo. And right here in this first input field, all we need to do to tell bash to run a command is give it the -c flag, give it the file path bin bash, hit enter. It's like, okay, oh, it liked that, all right. We can just give this whatever else. And oh, look at that. It executed the values in this config file at the end. And the first thing it saw was execute bash, like give me a bash shell. And obviously, as you can see by the prompt, running ID were root. And now we could do a word count, a character count on the root flag, which is always stored in root, the root folder, and is named root.txt. We can see that it's 33 characters long, and that is the root flag. So you could cat that file, get the hash, and throw it into hack the box, and get some points. So that's how we elevate to root there. And that's the end of the challenge, like actually this time, because we're root. Who has questions, like what can I answer about like this, just in general?
So what do you do when you're stuck? Like say you're obviously building on a lot of like prior knowledge that you already had to like know that you should do this. Like if you're in a position where you don't know what to do, like what do you usually end up doing?
So what I did like when I first was like starting out with this stuff is like I would just constantly like go like, you know, what are some common like privilege escalation methods? Like you would like Google stuff like that. And also very fortunately, Hack the Box has forums. And so every time a new box comes out, there's like a forum thread for the box. And people will be posting like, oh, like this box is great, blah, blah, blah. I solved it. If you need a hint, hit me up. And so if you get really stuck, you can like often like ask people questions like, can you point me in the right direction? Like, is what I'm looking at like a rabbit hole? And like they'll give you yes or no. Like nobody is allowed to like deliberately like give you an answer. I know I like, especially if the box is active. I'm like, this block is active, and I walked you all through it, and we recorded it, and we're gonna put it on YouTube. But we're gonna have to like keep this video private until the box gets retired, because you know there shouldn't be any walkthroughs for an active machine. But when you get stuck, like really, like you just have to like fall back to literally just researching and like reading stuff, and like eventually, like when you do it enough times, like you develop that methodology we talked about in the beginning, like recon, exploitation, post-exploitation, and then like you develop like your own set of steps. So like the biggest thing is just practice. Like you just have to do it again and again and again, and eventually like.
When you put up your reverse shell to get it to read as a GIF file, what was the, you put the magic byte right above the PHP, right?
Yeah.
What was the magic byte again? It was
GIF 89A, and then that's a semicolon at the end there, not a J.
So when you put that magic right there, that, because I know when I normally look at it, it's all in hex and whatever.
Mm-hmm.
Is there a reason why that suddenly that works when you put it in plain text? Is it not being interpreted as directly as the PHP file at that point?
the browser encodes it.
Oh, I
So
see.
it's reading
Yep.
it as an encoded string.
Got it.
Andrew, you had a question.
So
It's too funny when he's-
what would the documentation part be after?
Oh, okay, great question. So at this point, this is where we would go into thinking about how we can remediate these problems, right? So, well, this is the other challenge I had, but there's no time for it. So we did a couple things here. We bypassed an upload function, we abused the cron job, and we injected some code into a script that brings up a network interface, right? So these are the things that you would document. So like you would say, like for this system, like there is a vulnerable file upload function. We can bypass it by doing X, Y, and Z. From there, we can abuse this cron job, et cetera, right? So it's one thing to document and list out, you know, how you did this, right? But those steps, the documentation needs to be repeatable and it needs to be understandable, right? So when you read write-ups for like retired hack the box machines or vulnhubs, the steps outlined are like, they are repeatable. You can do exactly what that person did and get exactly what they got. And that's a critical part because especially for like certification exams like the OSCP or even the red team engagements or pen testing stuff that you might enter into, documentation is like the most important thing at the end of it because that information gets passed back to whatever internal teams that company has and they need to verify these things. So if you're doing like a bug bounty, for example, and you find a bug and you're like, oh, I'm gonna exploit this bug, and you're like, hey, like you contact, I don't know, Microsoft, and you're like, I found this problem with Microsoft Word. I can gain remote code execution by abusing Microsoft Word. They're gonna be like, okay, give us a proof of concept, give us documentation, and if they can't reproduce what you got, like it's kaput. Like it's not meaningless, but if they can't reproduce what you did, that likely means that other attackers and things like that, like actual malicious actors, won't be able to reproduce it. So if you can clearly outline how the problem is reproducible, that means other people can, you know, achieve the same thing. So documenting what you did, how you did it, and how easily reproducible it is matters. In addition to that, the documentation phase is important in terms of like classifying that data. So when you think about like documentation of a pen testing engagement or a red team engagement, and like you achieve like results like that, like you get root on the system, right? That is a blueprint for exactly how you can just own a server. So that documentation needs to be treated with like intense care. It needs to be labeled properly, like this is like top secret, only X, Y, and Z should have access to this, blah, blah, blah. Like that should not be information that gets like published on like your company's blog, like, oh yeah, we did a pen test for Microsoft, owned their like database server, here's how to do it, like, what up, give me my internet brownies. You know, so that's kind of like how you would handle documentation, and like a good way to start practicing documenting like your findings and like your steps is like doing hack the box challenges or doing vuln hugs, and as you like get through a step, just write it all down, like take notes and be as like specific as you can, because you want somebody to be able to read it and understand it as well as you do. Does that answer your question? So on the subject of documentation and like remediation, like how could we have like mitigated those problems how could we have mitigated all of those vulnerabilities that we so masterfully exploited today? Ken?
We could try and up the security on the upload function on the website, because without being able to upload that reverse shell, nothing else would happen.
Exactly. So like how would we achieve that like in a programmatic way?
We would have validated our inputs.
Yes, exactly. So it's one thing to be able to identify problems and document them, but like the most important part here is fixing them in a programmatic way, because all of this is code. Like everything's built upon code. Any service protocol that's vulnerable is because like the underlying source code is not engineered in the best way. So as Dan mentioned and as Kevin mentioned, you want to improve the security and validate the inputs. So all of this could have been easily stopped by making sure that the initial check on the file upload didn't just stop at once it found the first set of magic bytes. Like it should take that and be like, okay, we detected something here, and then scan the rest of the data to look for anything else that could be embedded in it. So what Ryan mentioned earlier, he was like, oh, well, we could just embed the script in like an image file. And like, that's absolutely valid, like you could do that. And the server would have just seen like, oh, this is an image file, and like that's it. But like there's obviously something malicious embedded within it. So improving input validation is one thing, but how would we remediate abusing the cron job and the last step there by it's the same thing. The answer is input validation. Like that's the biggest thing with this box. It's making sure that the inputs provided are checked sufficiently and that there's nothing malicious contained in them. And so we saw that in the final script that we used to escalate to root, there was a regular expression that looked for characters in allowed. And that is good, but you want to whitelist, so there's these two terms, there's blacklisting and whitelisting something. A blacklist is everything you don't want to allow, right? And a whitelist is everything you do want to allow. So writing a whitelist is a lot easier to help with input validation, because it's like, we are only accepting these characters. You could go on for days thinking about all of the input characters and combinations of things that like can be used maliciously, right? So in that case, instead of having a regular expression that checked for, like, if it didn't find, like, it would, instead of checking for characters like they wanted, they should have checked for characters they didn't want. So if they just had that regular expression, look for the semicolon, done. Like, that injection would not have worked. And really the same thing for the cron job that we used to escalate to the Gully user. Literally just check for a colon, a semicolon in the file name. If it's detected, like treat it as a string, ignore it, or just like quit the script. So input validation is the biggest thing we can take away from a machine like this. And that's all stuff you would add into your documentation. And with that said, that is pretty much the end of the workshop. I mean, like, I don't have anything else after this, just questions. But I mean, we can keep asking questions. if you guys have any. But other than that, we're done. Thank you so much for coming. I really hope that you learned something, and if you got lost anywhere or at some point it was hard to follow, like, definitely reach out to me or, you know, anybody on the club server, and like, we will help you like understand better. Cause like, I know you might not always wanna, you know, admit like to like, getting lost somewhere, which is fine. But if you are lost or you just wanna know more about something, like, absolutely hit us up and try to answer as best as we can. So yeah, thanks for coming.
Just a little fun fact. If you edit, just I'm working through it, looking back, obviously it's easier to figure out, but if you edit your PHP file prior to uploading it, you don't have to do the burp sweep.
Oh yeah, that's actually a really good point. Like,
Bypass that process.
we modified like the file extensions and stuff, and we saw that those headers were already like accommodated for us. So
But like, so if you go into the actual PHP backdoor file, and at the top of it, called PHP, put in the magic pipe, it skips the burp sweep.
oh, did that upload to
And it
oh,
automatically uploads successfully,
Awesome.
and then you pull a shell.
sweet.
Yeah, that's cool. This is fun.
Thank you guys so much for coming.
So, Brandon hosted a workshop.
Oh my god. You was gonna say that. That must have been like.
I ended up, I told my computer, like, every other service running in the background, prioritize it below normal, and then run my handbrake software as like real time, so that all my processing time goes to this 3-hour-long fucking file, and instead of 63 days, it cut down to like 12 hours. Are we still recording?
Yeah.
So you're recording in 4K, right?
Put on my phone? No, I think I set it to like 720.
You're recording your screen also, right?
Yeah.